motion, or particle movement calculus problems. Now, let's attack this guy, but before we start reading stuff and getting all confused, let's review some calculus vocabulary that is very important when coming to this, because, you know, half of understanding calculus is understanding how to read it. First thing is, what is x? What does x represent? It represents the position, or in some cases you can say that it represents the distance, but position is the key. So the label for x would be meters in this scenario. Then you have x prime. X prime is velocity. Velocity is different than speed, but a lot of times people use the term velocity in place of speed. Velocity also tells you the direction, not just the speed. So if you're a particle or object, whatever it is, if it's moving left or right, but we'll get to that in a second. Then x double prime would be your acceleration. When x prime is positive, then you're moving right. When x prime is negative, then you're moving left. So I'm just going to spit out all this vocabulary here for you guys, and we'll actually do this problem and talk about these in more detail. X double prime is when velocity is getting more positive. And x double prime, when it's negative, it's when velocity is getting more negative. Now that's kind of weird to say. A number getting more positive and a number getting more negative. And so I want to give you guys some extra stuff here. It's kind of like clicking on this and blowing it up. I want to give you some extra stuff here to help you understand what it means when the velocity is getting more positive or when the velocity is getting more negative. So here you go. We got to talk about it in two scenarios. So when f prime is positive, x double prime, when it is positive, is accelerating. It is speeding up. Or you can say that it is moving faster and faster. When x double prime is negative, we are decelerating or speeding down. That is when we're moving slower and slower. Okay, now this probably makes most sense to you, because most of the time when we're talking about acceleration, we are only going in one direction. And when we go in that direction, we usually are going in the right direction. So this is when we're moving right. This is what acceleration means. Well, what about when we're moving left? What does acceleration mean? Here you go. So when f prime is less than 0, we are decelerating. What? We're decelerating? Yes. Even though x double prime is positive, we are decelerating when we are moving left. When x double prime is negative, we are accelerating. Now notice the difference here though. We are speeding up, moving faster and faster. Oops, just fixed it. Sorry about that. When x double prime is positive and we're moving to the left, we are decelerating. And this is what I fixed. We are speeding down. We are moving slower and slower as we move to the left. Okay, so this is extra stuff. Or you can just think decelerating because we're moving left. When x double prime is negative, we are accelerating, meaning we are speeding up and moving faster and faster to the left. Remember, we're moving to the left here. Okay, so when x double prime is negative, we can mean two different things. Here, when we're moving to the right, we're decelerating. Here, when we're moving to the left, we're accelerating. So I guess you can say when the signs are the same, we are accelerating, and when the signs are different, we are decelerating. So here's the short and skinny of it, okay? If we are moving to the right, if this is f prime, if we are moving to the right and we are accelerating, this is f double prime, then, or I shouldn't say accelerating, if f double prime is positive, then we are accelerating. Our speed is accelerating. And then if we were positive and then negative, that would be deceleration. I don't want to spell it all. Now we're moving to the left and our f double prime is positive, then here you would be decelerating, meaning the speed would be going slower. Or moving to the left and our f double prime is negative, we are getting more negative, then you would be accelerating. There you have it. There's all the notes and vocabulary that you need for doing motion problems. Now let's do this problem.